Well, I got up late this morning. It's only 5:05. Oh my goodness. It's so crazy. But I'm excited because look at this. It's the last one, at least this time, and then we'll do another one and another one and another one. But for now, this is the last one. January 2016, the last one before your June 2016 Regents Exam. Whoo-wee! Man, so exciting. So, I am Mr. Krause. This is Mr. Key working for you today. We are going to do right now part 1. Now, I'm going to do problems 1 through 12, but because I'm having problems with my computer, because my computer's old, slow, and yucky, I'm only going to do 1 through 4, and then I'm going to break it up after every 4 problems, so there's going to be a little glitch, but you won't see much. But we're going to do all 1 through 12. By the way, if you really want a well-organized look at these can be found at www.mrkrausemath.com. Let me show you what that looks like. I'll use that calculator later. I'll show you what that looks like, and then I'll get rid of this. It's right here. Just go to mrkrausemath.com. You'll see my ugly mug there. Right there I am. And up on the top, you'll see all this stuff up here, but this is the one you want. Regents Review, Algebra 1, Common Core. Now, when you come here, you'll notice I've got first a copy of the exam. You can click on that. Here you can click on and get the copy of the multiple choice answers. And then I've got the videos all broken down. Now, I'm working on, I finished them all, except for these. I'm working on this one right here. But, no, not all those, just this one right here. I'm just working on all these right here, this one right here. All right, and then we'll be done. So if you want them all organized, there they are. They're all in a nice organized format. There's no guessing. You just come right here, boom, 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 start knocking out the problems. Make sure, though, that you have done the problems yourself. Make sure you're not here just to copy my work. All right, let's get rocking and rolling. Start with problem number. By the way, hit the subscribe button. It's down here somewhere. Down here. Hit that subscribe button for me. It allows me to do a few extra things. Trying to get to 3,000 subscribers during this testing season. That would be sweet. I only got like 1,200 to go. All right. The function blah, blah, the minimum value occurs when x equals. Now, hopefully your teacher has shown you. I'm going to show you 2 different ways to do this problem. Hopefully your teacher has showed you that this is vertex form of a parabola. You should have known it was a parabola because there's a squared term right there. So it's a parabola that's going to open upwards like this, right? And so the minimum point is going to be the vertex down here, which is at 2, 4. So it says, this is a tricky question. The minimum value occurs when x is. Can I tell you I missed this question? Because I just said the minimum value. I'm like, oh, minimum value, boom, highlighted. I even highlighted it, minimum value. I was like, oh, minimum value. And I said, oh, yeah, the minimum value is 4. Boom, done. Came back, looked at the answer kit. I'm like, oh, maybe I should actually read the problems like I say in my videos. Read the problems, kids. Read the problems. The question is when x is. So the answer to this question is number 2. Man, it's embarrassing. All right. The graph below was created by an employee at a gas station. Now, what I want you to notice is that it is a perfectly straight line, which means the rate of change, otherwise known as slope. I know they don't like using that word anymore. The slope is consistent throughout. Consistent. I don't know if it's E-N-T or A-N-T. That's why I teach math. Oh, embarrassing. It's throughout. Throughout. Whatever. That's what I used to do in class in English. When I didn't know how to spell something, I spelled it like that. Kind of embarrassing. I know. Whatever. That's why I went into the math world. Actually, I joined the Army. Then I went into the math world. Hence the nice haircut. Oh my gosh, I just got a little buzz yesterday. It's looking so sweet. Fly. Anyway, everywhere you go, the slope will be the same. Nothing's going to change. It's not any steeper any place along here because it's linear. So, if 10 gallons of gas was purchased, $35 was paid. Let's see if that's true. 10 gallons of gas, $35 was paid. Nope. That's like $37.50. Ooh, that's going to become important. Wait, $37.50 for 10 gallons of gas. Doesn't that mean that's $3.75 a gallon? That might come in handy later. Every gallon of gas was $3.75. See what I'm saying? I think that's the answer. For 2 gallons of gas purchased, $5 was paid. Nope, $7.50 was paid. 2 times $3.75. Guess what that is? $7.50. Oh, yeah. If 0 gallons of gas were purchased, 0 miles were driven. No. You could have my car. I have a 2013 Volt. I buy gas about once every 6 months because I don't ever use gas. So I could be driving a Volt and just not use gas. At any rate, the answer is choice 2. Moving on. Next page. I remember I'm going to pause at every 4. For a recent movie, the function blah, blah, blah models the revenue earned Y in millions of dollars for each week for its real estate. Based on the equation, how much more money in millions of dollars for week 3 than for week 5. So all I got to do is use this equation and my calculator. So I'll come over here. I'll go calculator mode. I use the TI Inspire. I should put a link to that in the show notes for you to show you what that is. 67 parentheses 0.61 parentheses raised to the, they said 3 and 5, right? We'll do 3 there. And then we're going to do it again. I don't like retyping stuff, so go there again. Boom, boom, boom. Hit the delete button, hit the 5 button, boom. And it said, what's the difference in millions of dollars? In millions of dollars. Millions. So we're going to subtract off, ding, 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 this. And I get, $17 million. $17.0 million. There it is. That's the answer, kids. And one more, and then we're going to pause. Given the following expressions, which would result in an irrational number? Now, the only way to get an irrational number is I can multiply. See, if I multiply these two together, I get the square root of 25. But the square root of 25 is 5. Even though these are two irrational numbers, when I multiply them like this, I get a rational number. These are two rational numbers. That gives me rational. The square root of 49 is 7, so this is just equal to 21. That's rational. This is the only one, and if you put this in your calculator, you would see you did 1 divided by 2 plus the square root of 2. You would get, see, irrational. Total crap. All irrational. So the only one that would give you an irrational number is choice 1. That's the right answer. All right, I'm going to pause. I'll be back. Had a little opportunity, get a little Dunkin' Donuts in me. By the way, Dunkin' Donuts is a sponsor of the show. They paid me exactly nothing. But the only reason they sponsor you this show is because they keep me awake at 5 o'clock in the morning so I can enjoy this, or actually look like I enjoy this. Anyway, we're back. We're still on January 2016. You guys probably didn't even know I left, man. It was like, bloop, blip. I didn't even look like any time, but it was like a minute or two. So let's see what we got here. We've got a solid line, so that's, because we're trying to find what this equation is. Solid line, that's got to have an equal to in it. Here we go. Hold on. Silly computer. All right, so we got a solid line, so that's got to have an equal to in it. Do I have an equal to in it? They all have equal to in it. All right, we're shading up, so that's greater than or equal. So this one's got to go, and this one's got to go. It has a y-intercept of -1, 2, 3. This has a y-intercept of 2. There's the big winner, number 2. Switch the page, kids. Oh my gosh, math is so much fun. All right, so this wasn't a joke compared to like previous tests, this problem. Oh, they get you later on some of the extended response. They get you later. Oh yeah. So we want to figure out what the new formula, what is R equal? What does R equal? So we take I equals PERT, P-R-T, and we want to solve for R. Really? Okay, so I divide by PT, and if I divide by PT, I get I over PT, I over PT. Wow. That was a tough problem. Then it says, which equation is equivalent to this? So let's see here. I'm going to distribute this x. So I'm going to get y minus 34 equals x squared minus 12x we're going to bring this negative 34 over here. And when I bring it over here, it's going to become positive 34. So I end up now with y equals x squared minus 12x plus 34. It could be one of these two. Let's simply factor it first. Let's see if it's even factorable. Chink, chink, chink. X and x, 34. The only numbers that are going to 34 are 17 and 2. Ah. But they don't add up to 12. Huh. Well, that can't be it. By the way, I'm going to show you two different ways to do this problem. I would say the way I'm doing it right now is going to be the hard way. The next way is going to be like, oh my gosh, Mr. Krause, why didn't you show us that first? It would have been so much easier. I show you usually the hard way and then the easy way only because you got to have multiple ways to solve the equations. What you want is at least two ways to solve the equation. We're going to do this one by completing the square. And we're going to put it in vertex form because it doesn't factor to these two, I don't think. So plus 34. Now, if I add something here, I have to subtract it here in order to keep the equation equivalent. Now, by completing the square, it says we're going to take half the negative 12. Half the negative 12 is negative 6. And square it, you get 36. But if I add 36, I got to come over here and subtract 36. And 34 minus 36 is minus 2. And so there's the big winner right there. Now, I think that's the hard way. So I'm going to go back up to here. And I'm going to go all the way back and make sure I don't make any mistake. And I want to solve for y. So the only thing I'm going to do is bring that 34 over and put it as positive 34 here. So now I've got y equals this thing right here. And I decided that y was equal to this thing. So I'm going to come over my calculator. I'm going to check it out. So watch out. Watch how easy this is. Here's another way to do this problem. So x parenthesis x minus 12 plus 34. Oops. Not even sure what the hell that means. All right, guess apparently we don't like this. So we're going to get out. No. I don't think there's anything in my calculator. Let's clear this. I don't know what's going on. It's as easy as that, kids. Of course, the calculator's got to work right. Sometimes it doesn't like input from here. So let's try this again. So let's do this. X. And sometimes you got to hit the times button. For some reason, you got to hit the times button. Times x minus 12 parentheses plus 34. Please work this time. There we go. And then I'm going to hit the tab button. Now, if my answer is correct, when that blue graph you see right there will evaporate. It will go away. So we're going to do x minus 6 squared minus 2. So if that's true, that thing's just going to go right away. Let's see. Boom. Hit enter. Gone. You see? So that's the right answer. Easiest way to do it. 8. Last problem. Then we're going to take a little break. I am. You aren't. Of course, I got to redo this. I don't know why. All right. So here's our equation. Now, as soon as you see this equation, you should already have a good idea what's going on. You should have discussed this enough. This is your starting amount. In here, this, put over here, should have been 1 plus or minus some percentage. And so the question is, what does the 1.02 stand for? So it's 1 is always there, plus, and we had to add 0.02 to that 1 in order to get 1.02. So 1.02, the O2 represents 2%. And because it's adding, it's 2% growth. All right, and so there's the answer. Be careful, Be careful. Remember, when you put the numbers in there, they become decimals. But we're going to use, it represents 2% and its growth. So there's the answer. All right. Bye. Okay, had a little coffee break. Oh my goodness, I'm back. Boom, boom, boom. Find the zeros of this function. Well, the first thing I'm going to do is, I'm going to show you two different ways to do this problem as well. I'm going to take out this 2, and I'm going to be left with x squared minus 2x minus 3. 2, now I can factor it. X and x minus 3 and plus 1. So my 2. By the way, these are not the answers. These are the factors. These are the factors, not the roots or zeros. This could be roots. It's an R. Or zeros. I have to change pen tips. My pen tip's going. The roots are x equals 3 and x equals negative 1. 3 and negative 1. The winner is choice 1. Now I could come over here and graph it, hopefully. Let's go get a new graph. Try doing it this way. Ding, 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 ding. And I'm not going to bother even factoring it. I'm just going to type it in as it originally was. 2x squared minus 4x minus 6. Hit enter. And the great thing about this calculator is, if you hit number 5 and you hit graph trace, it will tell you what the roots are. It will tell you, hey, there's a 0 at negative 1. Ding, 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 ding. Go to the right. Go to the right. Go to the right. There's a 0 at 3. And it even tells you what the zeros are. My goodness, are you kidding me? All right, so this thing here is subtracted from this thing here. All right, so subtracted from this right here means backwards. Don't forget, we are backwards. We're backwards. So what we're really doing is taking 5x squared and we're subtracting off 2x minus 3 squared. Now be very, very careful. This thing needs to be double distributed, and this negative is a huge problem. So the first thing we're going to do is double distribute this puppy. So I'm just going to do it all one time. You know that this means squared means multiply it by itself. So I don't need this anymore. Get rid of you. Okay, so 2x times 2x is 4x squared. So then we've got minus 6 and minus 6. That's minus 12x plus 9. Negative times negative is 9. There's another tricky part of the problem. So now what you got to do is you have to distribute this negative. So now what I have is 5x squared minus 4x squared plus 12x minus 9. So these combine to make x squared, and there's the rest of it. Plus 12x minus 9 plus 12x minus 9 is choice 3, the big winner. And finally, the last two problems but for this video. Ooh, this is a tough one. So Joe has a rectangular patio that measures 10 feet by 12 feet. He wants to increase the area by 50% and plans to do so by adding lengths of equal length to each one. So let's just look and see what the area is right now. The current area of this is equal to 10 times 12, which is 120. There's my current area. I want to increase this by 50%. So there's two ways to do it. 50% of this would be 60. So I want to increase it by 60. So it would go to 180. The other way I could do it is just take 120 and multiply. If you want to increase by 50%, you multiply by 1 plus 0.50, because 0.50, doesn't that represent 50%? And if you do that in your calculator, you would end up at 180. So the answers with 180 are the ones we want right now. I guess that's it. So let's see. Let's say my width is 10, and I want to add x to it. So that's my new width. My length is 12, and I want to add x to it. And these are this is my new width and my new length, and I'm going to multiply those together, and I want it to equal 180. And so the big winner is right here. That's my big winner right there. All right, next problem. Last problem. When factored completely. Okay, I'm going to show you two different ways to do this one, kids. First thing you're going to do is take out the x. Notice they all have the x taken out. X squared minus 13x minus 30. Then we're going to factor it. Leave the x out front. Two numbers that multiply to negative 30 that add up to 13 are x minus 15 and x plus 2. So the big winner here looks like this one. Now, I said I was going to show you two different ways to do it, didn't I? That's because I really like you guys. I do. I really do. Let's see. The original was x cubed minus 13x squared minus 30x. I believe that was right. Oh, funky. Crazy. There. See how that... So I had to get it over there so I could see it. Because it's a cube, it should have 3 roots, right? 1, 2, and 3. So what we're going to do is we're going to take our answer, we're going to graph it, and hopefully that purple one goes away. So x. All right, how about this? X. This calculator, by the way, calculator works amazing. Not with my tablet for some reason. When I'm working on a computer, it doesn't work great. X plus 2. X minus 15. X minus 15. That meant positive 15 was a root. That's why I had to get way out here. And if I hit enter and that purple goes away, I know I got the right answer. All right, sorry, kids. It doesn't like when you don't put a times between things like that. Okay, some reason you got to put a times. All right, boom, boom. Purple's gone away. Got the right answer. That's it, kids. 1 through 12 is done. Hit subscribe. Hit like. Tell me how much you like my videos. And keep coming back. And share them on Twitter or Facebook or whatever with your friends. Instagram. Let them know. They can come here. Get some help. All right. Bye, kids. Bye.